In this video, we're going to talk about kinematics part 1, and specifically, we are going to go over the vocabulary for position, distance, and displacement. So by the end of this lesson, you should be able to explain the difference between position, distance, and displacement, and calculate the distance and/or displacement of an object. First, some basic vocabulary. When we talk about kinematics, it is just a fancy word meaning that we are describing motion. So it's just about how objects are moving. Whether they're moving with a constant speed or speeding up or slowing down, that's what kinematics is all about, just describing how something's moving. Dynamics is going to be the why an object moves. So if I push something, well, why does it move? Because I pushed it. I applied a force to it. All right, so position. Position is just an object's location in time and space. And whenever we have an object, we have to define that position with reference to an arbitrary origin point. And when I say arbitrary, it's because we can define what our origin is with whatever's convenient for us. Now, the variable x is what we use for the variable for position. So we're going to go through a story with Marco walking from school to the store. And we'll look at how his position changes and then his distance and displacement. So Marco leaves school at the end of the day to walk to the store, which is 1,000 meters to the east. So Marco leaves. Oh, sorry, the origin is going to be the school. I could make the origin the store if I wanted to. It doesn't matter as long as I'm consistent. The school, since that's where he's starting, is convenient as my origin. Now, all the positions that we're going to talk about will be defined as the distance from that school. And we're going to use the compass, so the north, south, east, and west, to define the direction. So at the school, his position is 0. So Marco leaves the school, and he gets halfway to the store before he remembers he left his wallet at school. So right now, Marco is 500 meters to the east of the school. Since Marco left his wallet, he has to turn around and run back to the school to look for it. So now Marco's position back at the school is 0 again. Marco can't find his wallet, so he starts to walk home slowly. And when he is 250 meters south of the school, he remembers that he has 20 bucks in his pocket and he can still get what he needs at the store, so he runs directly to the store. So Marco's location is now 1,000 meters east of the school. So even though he ran at an angle, his position with respect to the school is 1,000 meters to the east. So this is Marco's total path that he took. But his position is just where is he at any particular time. So now let's talk about distance. Distance is the total length of the path traveled by an object, in this case Marco. So if we want to find the total distance Marco traveled, we need to add the length of each leg of his journey. So he went 500 meters, and then he went back 500 meters, and then he went 250 meters, and then he went to this weird little angle thing. But since we know how far south he went and how far east the store was, we can use those as the legs of a right triangle, and we can calculate using the Pythagorean theorem the path for this portion of his journey is 1,031 meters. So we add that, and his total journey was 2,281 meters. When we're talking about distance, distance is something called a scalar, and only the magnitude matters, not the direction. So scalars. Scalars are concepts that can be described using the magnitude only. And magnitude is a word you really need to internalize, you need to memorize it, you need to know it. Magnitude just means what is the amount, not direction, just how much is it. But you still have to use units. Units always give your numbers size. So $2,000 is not the same as 2,000 pennies. You have to have units to identify your numbers. All right, so that was distance. Next we have displacement. Displacement is the straight line distance from where an object starts to where it ends up. So with Marco, he started at the school, he ended up at the store. So his displacement was 1,000 meters. Now for displacement, the variable we use is delta x. That's that triangle with the x. And the way we calculate that is the final position minus the initial position. So in this case, he was 1,000 meters away, subtracting his origin of 0, and that is 1,000 meters. So Marco's displacement was 1,000 meters. But displacement is a vector. So that 1,000 meters is the magnitude. To completely define a vector, we also have to have the direction. So we have to add that it's 1,000 meters east of the school. So a vector is a concept that requires a magnitude, an amount, and a direction. So it has to have both in order to describe it. So go ahead and try the quick check. I will add a separate video going over the answers to the quick checks that'll be right with this one.